Find the position vector of point R, which divides line MN internally in the ratio 2 to 3. Take the position vectors of M and N to be M, 3, 4, negative 6, and N, negative 5, negative 1, and 2. We can draw a sketch. We can draw a sketch like this. This is the origin. This is vector OM, vector MR. So we are being told, find the position vector of point R here, which divides line MN internally in the ratio over 2 to 3. So we are having 2 to 3 parts, which is 2 plus 3, giving us 5 parts. So it means that here vector MR will be 2 over 5 of M of vector MN. So we are told, take the position vectors of M and N to be 3, 4, negative 6, that is M. N is a negative 5, negative 1, and 2. How can we find vector OM? Vector OM, which is the same as M. How can we find vector OM? We are given vector OM. It is a 3, 4, negative 6. And we are given vector ON. We are given vector ON, which is N, and it is negative 5, negative 1, and 2. So how can we find vector MN? How can we find vector MN? Vector MN is given by vector ON minus vector OM, and that will be vector ON is this one here, negative 5, negative 1, and 2, minus vector OM is a 3, 4, negative 6, 3, 4, negative 6. It will give us negative 8, negative 5, and 8. That is vector mn. How can we find vector mr? Vector mr is given by, how can we find vector mr? Vector mr here. This O is our origin, so we can say that vector mr is 2 over 5 of mn. So vector mr is 2 over 5 of vector mn. And we know that vector mn is negative 8, negative 5, and 8. So we can say that vector mr is equal to 2 over 5 over vector negative 8, negative 5, and 8. 2 over 5 of negative 8, negative 5, and 8. And this is giving us negative 16 over 5, negative 2, positive 16 over 5. How can we find the position vector of point R? We are asked, find the position vector of point R. How can we find the position vector of point R? So the position vector of point R is OR. How can we find OR? OR. How can we find vector OR here? Vector OR. So from this our sketch here, vector OR is given by, when we want to find vector OR, it means that we start from the origin here. We go to M, then to R. We go from origin to point M, then to point R. So we can say that vector OR, which is the position vector of R, is vector OM plus vector MR. So we can say that OR is vector OM plus vector MR. OR is vector OM plus vector MR, and we know that vector OM is 3, 4, negative 6. Vector MR is here, negative 16 over 5, negative 2, positive 16 over 5. And this is going to give us negative 16 over 5, negative 2, positive 16 over 5. Vector OM is 3, 4, negative 6. Vector MR is negative 6 over 5, negative 2, and positive 16 over 5. This is going to give us vector OR which is equal to 3 minus 16 over 5, 4 minus 2, negative 6, plus 16 over 5. And this is going to give us vector OR is equal to 15 minus 16 over 5 to negative 2 negative 30 plus 16 over 5. And this is going to give us a negative 1 over 5 to negative 14 over 5. And this is going to give us negative 0.2 to negative 2.8. So we can say that the position vector of point R, therefore the position vector of point R is equal to negative 0.2 to negative 2.8.